Hi, my name is Iwei. Today I'm gonna um, introduce the topology data analysis. So why I want to talk about topology data analysis? Simply because I've seen people talk about network analysis in the class contribution for previous section. So I think it would be a great add-on if I introduce TDA to my classmates, since we are not only interested in graph of data itself in our class, I think we are also interested in the ways that how we could interpret them. And in my point of view, TDA is a perfect tool for us to use in order to derive useful topology information from the graphs. Uh, and those graphs are technically not well organized, such as cloud data or clustering. Um, and also TDA has been researchers' favorite tools in many fields such as neuroscience, cancer study, or even network security. Some researchers have successfully explained certain function of neurons with the help of topology data analysis. And also a recent study that used spatial model to try to simulate cancer or even protein growth has largely based on the topology data analysis. And in here, figure one showed it is an example of visualization of topology data. It is the data of a DNA microscopy. And why I want to talk about topology data analysis. So I read a, here's the answer of a professor. He is also the founder of Topology Data Analysis. He said, in his point of view, TDA is created in order to analyze data with high noise and in high dimensional spaces. Um, since most of the data we have been working on are basically well organized and can be classified or clustered by using simple regression tools or classic classifier. I think it is also important for us to be able to see information behind data that restricts our ability to visualize them. And so this is why I want to introduce this topic to the class. In the next slides, we will see how TDA work. So some mathematics behind TDA. So first of all, what is geometry and topology? Since topology is like, I believe it's basically new for most of us. So topology is a branch of mathematics to deal with geometric information. Since most of the time, cloud data includes geometric information such as distance formula, topology is essential to deal with this qualitative geometric information. And geometric formula helps deal with data cloud, which often includes data with distance functions. As I said before, there are many tools from topology that can help us deal with this information. For example, researchers often find themselves interested in homology groups when come across topology data analysis. We will introduce homology, the definition of homology groups later. But just a brief introduction. Homology group is an algebraic formula to quantify topological features in a space. And also for those who never learned about topology, I've also introduced a general principle of topology. That is, topology of two spaces is the same if one can continuously deform to the other without breaking. This principle allows us to figure out geometric factor. The graph showed uh, how a cloud data of hands, so here, being reconstructed into something like a diagram on the right. So here, it is easy to see that after topology data analysis, we figure out some features, um, but still preserve the geometric feature of the original data. However, even though we can study the geometric properties out of the data, how we gonna summarize our overall information? That is, how can you tell the relationship between each object from the geometric point of view? So here I will introduce the idea of functoriality, and it will give us the solution. So here's the definition of functoriality. So it provides explanation to the map of the objects rather than just focusing on the objects that are being studied. Now here's the example of how functionality work under clustering scheme. So just consider our data X and axis varies by time. So x t1 t2 means that the data occurs between time t1 and t2, and siege is just denoted as a set of clusters. So clearly, if the cloud diagram, so this is a cloud diagram, is functorial, then you can have a diagram look exactly like figure 2. So it implies that the single cluster that happened at time t0 can break into two clusters in the interval of t1 and t2. And since we know how to summarize our information from graph using the idea of functionality, let's focus on the homology group we introduced previously. So here's the definition of homology. So for P greater than 0, actually it should be greater or equal to 0, the P's homology group is a quotient group denoted as HP. Um, Intuitively speaking, homology group classify the cycles in a cycle group by putting together those cycles in the same class that differ by a boundary. If two cycles are in the same homology classes, then we call them homologies. The reason that homology groups are so attractive in topology data analysis is because homology groups are more computable. You can easily find tools that can quickly calculate the homology of any simplicial complex. These properties form the pros and cons of topology data analysis, which I will going to talk about in the next slides. So pros and cons about TDA. So the problem of TDA is that invariants are very hard to compute. And unlike other classifiers such as KN or SVM that can be accessed easily through Python library, there is no library available right now for TDA that you can simply import to your program, which makes it not applicable. However, with the development of computational power, maybe in the future we'll be able to compute environments of topology efficiently. And also, I hope more people could contribute in the construction of TDA in the future. And also, one of the drawbacks of TDA is that it cannot give you more information other than topological information. That is saying TDA is not suitable for those data or graph that can't interpret geometrically. Like most of the analysis, we have to use them wisely. And there is advantage of TDA, as we discussed earlier. It is a perfect tool to get around with noise and deal with high-dimensional data. Sometimes TDA will give you very valuable insights. And yes, and this concludes my introduction of TDA. And I wish this short introduction will get you a rough idea of of how TDA works and what makes it so compatible in the recent years. And here's my reference, and thank you very much.